Hello everyone, I am going to explain question number 2 from exercise 3.3 and this question belongs from 12th class maths. So question 2 is, if A is a matrix and B is another matrix, then we have to verify the following results. So there are two results, among them I am going to prove the second part, and first part similarly you can do it. So let's start it. Now what the question is, the second part is, A minus B transpose is equal to A transpose minus B transpose. Means if you will, what is the meaning of left hand side is, first subtract the matrices A and B, then whatever be the resultant matrix, that matrix transpose when you will do, that is going to be equivalent to the A matrix transpose minus B matrix transpose. So we have to prove this separately. We have to prove the left hand side and right hand side. So I started the second part. As you can see, I wrote here second part. First I wrote the given matrices A and B, which is given to us. Now since we need the A matrix transpose, so I found A matrix transpose initially so that I can substitute the values when I need. So this is the symbol of A matrix transpose, means transpose of matrix A. And now how to do that, you know, that is the rows of column, the rows of matrix A will change to the columns. Now this is the first row, so this first row will change to the first column, and second row will change to the second column, and third row will change to the third column. So I hope it's clear to you. In the same way, B matrix is given to us. So B matrix transpose we have to do. So the rows will converge to the column. So this is the row. So this first row just write in the form of first column. Second row write as a second column, and first row write as first column. Means rows and column will interchange. And after obtaining A matrix and B matrix transpose, I assume them as equation first and equation second. We have to verify this result. So I started to solve the left hand side first. So in left hand side, what we have to prove, A minus B subtraction first we have to do, and then after that whatever result we will get, that matrix transpose we will do. So first I replace the value of A and B. From question I wrote this matrices which is available to us, and we have to subtract, and subtraction of matrices, you know, we have to subtract the corresponding elements. Means from here minus 1, this minus and minus becomes plus, so plus 4, then 2 here, then 2 minus 1, like this the corresponding elements subtract, and this transpose symbol will come as it is. Now find the differences, write the difference in the matrix, and then this transpose symbol will come again as it is. Now after all simplification, now we will do the transpose of this matrix. So same way, row will change to the column. So 3, 1, 8 is the first row. So this 3, 1, 8 is going to be the first column in the resultant transposed matrix. In the same way, 4, 5, 9 is the second row. So it will converge to the second column. Minus 3, minus 2, 0 is the third row. So this is going to be the third column. So like this we obtained our left hand side. Now we'll solve the right hand side, and we'll check that whether the right hand side solution is same with the left hand side or not. So in right hand side you can check the question. We have to prove A transpose minus B transpose, and A transpose and B transpose already we calculated in equation 1 and 2. You can rewind and you can see the matrices. So directly from equation 1 and 2 I replace the value of A transpose and B transpose, and now we have to subtract them. So I subtracted them. So corresponding elements we have to subtract. So minus 1 will get subtracted from minus 4. So it's going to be minus minus plus because of this minus symbol. And 5 will get subtracted from 1. So 5 minus 1. Then minus 2 will get subtracted from again from this 1. So like this. So corresponding elements subtract, and resultant matrix is this. So now from equation 3 and 4 you can see this matrix. Here you have 3, 4, minus 3. And in equation 3 also you have the same thing. See 3, 4, minus 3. So the left hand side and the right hand side both are same from equation 3 and 4. Means the matrices are identical. Now from equation 3 and 4 we obtain left hand side and right hand side are identical. So the required result is proved. So from here we can understand that if we have to do the transpose of difference of two matrices, then it is equal to the A matrix transpose minus B matrix transpose. Separately you can do and then subtract them. Now the question number 3rd is also of same type, so together I had done. So here the transpose of matrix A is available to us. So this is A matrix transpose, not A. So it's A matrix transpose and it's B matrix itself. And with the help of this, we have to prove the same result again. So again, I am going to prove the second part. So here A matrix transpose is available. So from there, I want A. So how we will obtain A? If you are going to do A matrix transpose again transpose, then that will give you A. It's a property. This matrix transpose just do again, so you will get the matrix A. So how to do? The row will change to the column. So 3, 4 is the first row. So 3, 4 will come as the first column. Minus 1, 2 is the second row, so it will change to the second column. 0, 1 is the third row, so it will change to the third column. So like this, from A transpose we obtain our original matrix A by doing again the transpose of that. It's a property. And here B matrix is available, so I done the transpose to obtain the B transpose matrix. So I assume them as equation 1, 2, 3, 4 because we need it. Now again we have to verify the same result. So left hand side I started. In left hand side we have to put the value of A and B. So A is from equation 3 and B is we assumed as equation 2nd. So here left hand side is A minus B. So I put here A minus B values from equation 3 and 2nd, and this transpose symbol I kept outside as it is, and subtraction we have to do. So corresponding elements we will subtract, and so it will appear like this. Subtract it, and after subtracting it, the resultant matrix is like this. 3 plus 1 is 4, minus 1 minus 2 is minus 3. Like this we obtain the resultant matrix here, and this transpose symbol will appear here as it is. And after all the simplification, now we will do the transpose of it. So the first row, that is 4 minus 3 minus 1, will change to the first column, and second row will change to the second column. So this is our left hand side. Now we will start the right hand side. I assume this as equation 5. Further we will use it. In right hand side we have to prove A transpose minus B transpose. That also A transpose is already available in the question. B transpose I had done, which is I selected from the question 4 as it is. I copied here. You can rewind and you can see already we calculated B transpose. Now we will subtract the corresponding elements. So this 3 will get subtract from minus 1. So minus minus is going to be plus 1 here. 4 will get subtract from 1. So 4 minus 1. This minus 1 will get subtract from 2. So corresponding elements of both the matrices is write with the minus sign, and then just subtract them. So we will obtain it. So you can see this is our right hand side. So 4, 3, minus 3, 0, and these are the elements, which is you can see it is same with the equation number 5. So conclusion is from equation 5 and 6 our left hand side and right hand sides are same, and so it's verified. So I hope both the questions are clear to you. So in this we need the concept of A transpose, and it's very easy. Only the rows you have to change to the columns, or you can say columns you have to change to the rows. Means rows and columns you have to interchange in by any way. So I hope these questions you might understood. Further, if you have any doubt, you can write in comment so that I can clear up your doubts. And now the contents are available in PDF form also, so you can see the description which is given below. Thank you for watching.